Okay, we're definitely in the home stretch here, so to speak. Section 17-4. The last section we're going to cover. Okay, it's going to talk about volume and surface area. If you're at all confused with these terms, you're probably not, but just to recap, so far we've talked about perimeter, which is just the distance around. Okay, and then when it was a circle, we just had a different name called circumference. Okay, area talks about how much surface something covers. Okay, so now we're going to talk about the term surface area, and it's like, wait a minute, what's the difference between area and surface area? Well, there really isn't a difference, other than now with surface area we're talking about three-dimensional objects, whereas before we were talking about two-dimensional objects. Okay, a square is a two-dimensional object, but if I turn it into a cube, now it's a three-dimensional object. Okay, and I can draw my little dash lines and all that. You can really kind of see all six sides of that cube now. So if I want to talk about the area of a cube, well, area of which side, right? If I just had a square, there was only one side to be talking about. Well, now I've got six sides of that cube. So the surface area of a cube, for example, is just going to be the area of all six sides added together. Okay, and that's what these shapes are going to consist of. Adding a bunch of areas of individual sides together to give you the total surface area of that figure. Okay, and then the volume is just going to be how much can this container, think of it as a container, how much can this container hold? Okay, a square can't hold anything, right? A circle can't hold anything because it's a two-dimensional figure. But a box, a cube, can hold something, or a cylinder can hold some volume of liquid in there, and that's what volume's all about. Okay, all right, so we got a couple of figures here on page 744. Okay, we've got the right rectangular prism, which is just a way of saying a box. Okay, we have a cylinder, right circular cylinder. Okay, then we got some slanty ones here. We've got what's called an oblique prism, another oblique prism. One has a square base and one has a triangular base. Okay, and I think you know where we're going to go with those. So we're going to calculate the area of these surfaces, the outside surface of these creatures, and then how much can we fit inside? What's the volume inside? Alright, so example 1. Again, some of these formulas I would expect you to know, but with this alternate learning, the exam's going to be on Math Lab, you're taking it at home, it's just, we're trying to limp our way through this semester, basically. So, you know what I'm saying. So anyway, alright. Volume, example 1 says find the volume, okay, the volume of a triangular prism in figure 17-108, which is the picture in the example here. Okay, so it's like a triangular shape on the bottom and the top, and then it's a prism. It's a three-dimensional figure. Okay, find the volume. Well, volume is going to be some area of a base. Now they're just using the term B for base, but this is really area of the base. Okay, times the height. Okay, so again, I've got some three-dimensional, I'm going to really botch this drawing, I know, but bear with me. I've got some three-dimensional figure here. It's a triangle on the bottom. It's a triangle on the top. It wasn't too bad. Okay, so I know that if I can find the area of this top, which is the same as the bottom, right, it's the same shape, and then I just multiply by the height, okay, so I'm going to have a certain height here, H, and this B we're calling area of the base. Well, I have to know my area of my triangle formulas, right, which is 1/2 what we call little base times height, okay, and the information's given to us. Let me just pull this off to the side here. We are told that a base here is 2.6 centimeters. Excuse me, a height is 2.6 centimeters, and all three sides of this are the same. They're all 3 centimeters, okay? So I know a base, and I know a height. I can find the area of the triangle. This 1/2 little base times height. So that's 1/2 2.6 centimeters times 3 centimeters. Okay, so what's that going to get me? I don't know. Let's find out. We've got 1/2 times 2.6 times 3. 3.9. The units are going to be centimeter times centimeter, so that's square centimeters. Okay, so that's just the area of what I call the triangle, and what our formula is calling capital B, the base, area of the base. Okay, so now I need to multiply that by the height, and we're told the height of this is 15 centimeters. Okay, so the volume is going to be 15 centimeters times 3.9 centimeters squared. So now I'm going to have centimeters times centimeters squared. I'm going to get a centimeters cubed out of the deal. And I'm going to get 58.5, what we call cubic centimeters. Okay? Volume is typically expressed as cubic something. Okay, now the everyday volume we use, gallons, liters, quarts, pints, cups, none of that has the word cubic in it. But there's a conversion between cubic, in this case centimeters, and gallons. Cubic feet and gallons. Cubic meters and gallons. Cubic whatever. Cubic yards and gallons. There's a conversion between all those. Okay, so typically when we're calculating a volume, we're multiplying 3 lengths together, and that's going to give us a cubic length. Okay? All right, that's example 1. Example 2. What is the cubic inch displacement, which is a fancy way to say the space occupied, of a cylinder in the figure? I'll pull the book over here in a second. Whose diameter is 5 inches and whose height is 4 inches. Round to the nearest 10. So now I've got a cylinder down here at the bottom of 745. I want to find the volume of that cylinder. Okay? Alright, I think we can handle that. Let me draw my little picture here. I've got a cylinder. It's got a height of 4 inches, and this is not very well, not drawn to scale very well because my diameter is bigger than my height, but I didn't draw it that way. But that's okay. So it's a little cylinder, a piece of pipe or something, right? And I want to know how much I can fit in there. What's the volume? Okay, well, volume, again, our generic formula is some B times H, where B is the area of the base. Okay, B is an area. So first I got to figure out an area of this base here. Now, it's a circular base, right? Circles have radius, circles have diameter. Okay, what are we given in this case? We're told the diameter of our circle is 5 inches. So if we remember the area of a circle, it was either pi times radius squared, or another way to do the same thing would be pi divided by 4 times diameter squared. Okay, either way. In this case, we're given the diameter, so maybe I'll stick with that second formula. Pi divided by 4 times 5 inches. And I'm squaring the 5 inches, so I've got to do that squaring operation first. So 5 times 5 is going to be 25. Pull over the old calculator here. I could plug it all in if I'm careful, right? Let me do that. So pi divided by 4 times, is this one? Let me make sure this calculator is going to cooperate with me. I think last time it didn't. It left it as pi. No, this time it's good. Okay, so I typed it in properly. Pi divided by 4 times diameter squared. Now, you got to be careful. If you don't have a proper calculator, this would be wrong. You would get a wrong answer just trying to type it in like that. So be careful there. So it's 19 point something or other here. 19.63495. I'm going to carry a lot of digits here, and then I'll round it in a second here. And that's square inches. That's just the area of the base. That's it. Well, now I got to multiply by the height to get volume. Volume is B times H. So I'm going to take 19.63495, and you can do this all in one shot, by the way. I've been calculating area separately and then timesing by the height. You could plug it all in one shot if you'd like. So now I've got inches squared times inches, so I'm going to get cubic inches from my answer. So I got to multiply by 4 for my last number, 78.5398 cubic inches, and the example is asking me to round to the nearest tenth, so that's right there. So 78.5 cubic inches. Okay? All good? Volume of a triangular prism, volume of a cylinder, we take the area of the base times the height. Okay? What about something that's more like a cone or a pyramid shape? Okay, that's going to be a little different now. If you look at our next example on page 746, this is going to be example 3. Let me pull the book over. Volume for a cone or a pyramid is now 1/3 base times height. Okay, 1/3. Now, where these formulas come from, we're not going to explore that. We'll accept them. Volume of a pyramid or a cube or a cone, is a 1/3 base times height. Now, base again refers to the area of the base, and height is the height of the figure. So let's take a look at our example 3. It looks like a little pyramid there. You see, it's got a square base, and it's got a triangular sides, your typical pyramid. Let's take a look at that. Let's see, can I draw such a thing without screwing it up? I doubt it. Oh boy, now I've said it out loud, I have to try. Yeah, alright, not too shabby. Okay, so I've got this. This bottom here has got some area, some base area, whatever that base is, and then I have to know how high it is, okay? And right now I'll label that as height h, volume equals BH. Okay, so what is the base of this thing? Well, find the volume of a pyramid that has a height of 28 centimeters, okay, so 28 centimeters high, and has a square base. Now that's a crucial piece of information, a square base. If it wasn't a square, I'd have to figure out a different way to calculate that base, but I'm told a square base, 15 centimeters on the side, so 15 centimeters there, 15 centimeters there, it's a square, no problem. Let's try to do it all in one shot here. So volume is going to equal the area of the base, okay, which it's a square, so it's 15 centimeters times 15 centimeters for the area of the base, and now times the height, 28 centimeters. There we go. I'm going to multiply those three numbers together. My unit is going to be cubic centimeters. So when I multiply, I'm sorry, whoa, big mistake. This is a cone. This is a pyramid. It's 1/3 base times height. You probably caught that and said, "Hey, dummy, you forgot your 1/3," and I appreciate you catching that. Okay, sorry about that. It's 1/3 base times height for a cone or a pyramid shape like this. Okay, so all right. Good, we got it caught here. So when you multiply 1/3, which really means divide by 3, right? If I were crunching this, I wouldn't necessarily type in 1/3. I would type in 15 times 15 times 28, but then I would divide by 3. That's the easy way to do it. We get 2,100. 2,100 what? Cubic centimeters. Okay, in the medical profession, you hear that term cc, cubic centimeter. Okay, that's a shorthand way to say cubic centimeter. It's a measure of volume. 1 cc, by the way, is equal to 1 milliliter in metric. Okay, so that's whatever. Sidebar. Okay, all right, there we go. 2,100 cubic centimeters in our little pyramid there. All right. Let's see. Our next example, I don't want to get too goofy. I'm going to skip example 4. What example 4 is it takes like a cone or a pyramid and then it chops off the top and says, hey, let's calculate just the area of that part that remains. This part here, it used to be, if you look over here, it's like taking a cone and chopping off the top and then figuring out the area of what's left over. Let's skip that one. It's an exercise in plugging numbers in, but let's just do things that are more familiar to us. A sphere, okay, a ball. The very bottom of 747, volume of a sphere. It's a formula, right? Here's one. I probably would not expect you to memorize some of these formulas because it's too much. Volume of a sphere. The book writes it as 4 pi r cubed over 3. Another way to convey the same information is 4/3 pi r cubed. That's the way I have it committed to memory. 4/3 pi r cubed. Okay, same thing, different way to write it. Alright, so all we need to know for a ball to figure out the volume, a sphere, is all we need to know is the radius. Alright, so example 5 says find the volume of a sphere that has a diameter, of 90 centimeters. Volume of sphere with diameter equals 90 centimeters. Okay, now we could rewrite this formula for diameter. It gets a little messy to do the switch there because I am cubing r. Okay, so I'd be cubing d over 2. I would be dividing by 8, which would be dividing by 24. Rather than complicate it, let's just say, okay, we know radius is half the diameter, right? So let's just figure that out right now. So 90 centimeters divided by 2. So the radius is 45 centimeters. Okay, and then we can just stick with the formula we know. Volume equals 4/3 times pi times 45 centimeters. But now I'm going to cube that 45 centimeters. Okay? So, again, this calculator, I can pretty much plug it all in. 4 divided by 3 times pi times 45 cubed. Be careful just plugging it in any old calculator, okay? The scientific calculator can tackle that problem like that. Okay, otherwise be careful. Make sure you cube your 45 first, then you can multiply by pi, then you can multiply by 4 and divide by 3. You can think of it that way. Alright, equals. What do we got here? Whoa, baby. We got a big number. Volume equals 381,703.5. What's the unit? Cubic centimeters. Okay? And this probably asked us to round. It did not ask us to round. So on a big old number like this, the 0.5, I would probably round that 0.5 off, right? Or, I mean, round it to the tenths. That's what the book did. So we'll call it 381,704 cubic centimeters. Okay, sweet. Alright, that's volume. Hold on one second here. Wait. Ooh, baby. Yeah, example 6 is going a little beyond. It's asking us to calculate the weight of something based on its volume, and then we would know it's what's called its density, which is mass per unit volume, and that's a little more than we're going to go into. We're just going to calculate volumes and surface areas with this section. So we'll skip example 6, and we'll go ahead and pause the video here and start up the next one. We will talk about surface areas on the next video.